All right, let's just dive right in, because we have a genuine puzzle on our hands today. We're talking about these incredible AI models that can write poetry, they can write code, but if you give them a simple grade school math problem, a lot of the time they totally bomb. How on earth is that even possible?
It's a great question, isn't it? I mean, these large language models, they seem almost magical, but they get tripped up by the same word problems that an 8-year-old struggles with. So today, we're going to unpack exactly why this happens, and then we're going to look at a brilliantly simple solution that is completely changing the game.
So what is really going on here? Well, the best way to think about it is like this. Imagine a student who is an absolute genius, but gets distracted by, everything. They have all the knowledge in the world, but if you bury a math question inside a story with a bunch of extra details, they get lost. They start focusing on all the wrong things and just completely miss the point. And that is a perfect picture of what's happening inside these AIs.
And that gets us to the absolute heart of the matter. See, the AI isn't failing because it can't do the arithmetic. It's failing because it can't properly read the problem. It has a language comprehension issue. It has a hard time figuring out what's actually being asked when there's a bunch of distracting info thrown in. And that's the key. We don't need to fix its calculator, we need to fix its understanding.
When researchers really dig into these mistakes, they pretty much fall into 3 main buckets. First, and this is the big one, are the semantic misunderstanding errors. That's where the AI just gets plain confused by the wording. Then you've got your simple calculation errors, 2 plus 2 equals 5. And finally, there are step missing errors, where it starts off on the right track, but then just forgets a critical step along the way.
And wow, this chart really tells the whole story, doesn't it? Just look at that. Semantic misunderstanding is, by a huge margin, the biggest culprit. A lot of the older methods tried to fix those other 2 little slices, but they were totally missing the forest for the trees. The real challenge is teaching the AI how to cut through all the noise.
So, how do you fix a comprehension problem? Well, a group of researchers came up with this really elegant way to tackle it head-on. It's a technique called the DUP method, and you can basically think of it as creating a super simple, focused study guide for the AI. So DUP, it stands for Deeply Understanding the Problems. And the logic here is just super straightforward. Before the AI is even allowed to touch the numbers, it's forced to first figure out what the actual question is, then pull out only the information it absolutely needs, and only then can it try to solve it. It's a lot like how a person learns to study effectively, right? And here's exactly how that little study guide gets made. Step 1, the AI has to find the real question that's buried in all that text. Step 2, it pulls out only the essential facts. And finally, step 3, it solves the problem with blinders on, using just that information it pulled out. Let's actually see it in action.
Okay, here's a classic word problem. There's a lot going on, right? We've got cousins, we have birthdays, different ages. It's really easy for an AI to get sidetracked by the fact that they're cousins, or some other random detail. So how does the DUP method handle this?
Okay, first, the DUP method makes the AI create its own little cheat sheet. It has to identify the core question and ignore everything else. Then it isolates only the essential facts that it needs to find the solution. All that fluff about them being cousins, it's gone. This is just the raw data it needs to get the right answer.
And now for the final step. We give the AI the original problem one last time. But here's the trick. We also give it its own notes, that core question and those essential facts as a helpful hint. This basically acts as a guardrail, keeping its brain locked on the target so it doesn't wander off.
And with that focus, boom, look at the result. The AI gives a perfect, clean, step-by-step solution. Raymond is 37. His son was born when he was 23. So his son was born 14 years ago. It's simple, it's direct, and it's correct. Now this approach clearly works, but the real question is, just how well does it work?
This is where things get really, really cool. We're about to see the payoff, because this simple study guide idea didn't just give it a little boost, it absolutely shattered records. To see how successful it was, the researchers used a standard test called the GSM 8K benchmark, which is basically just a huge list of tricky grade school math problems. They put the standard method, which just kind of tells the AI, let's think step by step, up against their new DUP method. And here we go, the results. The standard method was already pretty darn good, getting it right 94.6% of the time. But with the DUP method, that number shoots all the way up to 97.1%. That is a huge leap in performance, and it was done not by making the AI bigger, but by making it work smarter and with more focus.
And let's be really clear about this. 97.1% isn't just a slightly better score. It is a new state-of-the-art record on this benchmark. It's the highest performance ever recorded for this kind of AI model in this kind of test. And what's amazing is this technique works across a whole bunch of different kinds of reasoning tests, not just math.
Okay, so this whole thing is about way more than just AI's acing math tests. The success of this DUP method actually points to a much bigger idea about the entire future of artificial intelligence. So let's just recap the big takeaways here. First, we've learned that the biggest roadblock for AI and complex reasoning isn't calculation, it's just basic comprehension. Second, a simple, logical framework that just forces the AI to focus can have a massive impact on performance. And third, and this is the big one, it suggests that the best way forward for AI might not be just building bigger and bigger models, but teaching our current models better ways to think.
And that leaves us with a really fascinating question to chew on. We're always chasing bigger, more powerful AI. But what if this proves that the next great leap in artificial intelligence won't come from more raw power, but from teaching it a deeply human skill, the simple ability to focus?